Hey everybody, today we're doing another differential equation problem, and this time we're going back and we're doing exercise 2.4, and we're doing what is called exact equations. And I know I did a problem back in a couple months ago on this, but I want to do a couple more because I know that this can be kind of tricky. They can be kind of tricky problems too. But anyway, I'm going to do the steps. I'm going to do the steps, and I'm going to do read a little bit of the definition, okay? Because again, the definition is too long. I will only do just a little bit because again, this is a very small board. As you see that I try to put as much as I can of the information, but it's not the board is not big enough. But anyway, first I'm going to explain a little bit, okay, of the exact differential equations. Okay, the exact differential equation is an equation that contains two variables. Okay, two variables, and so in this case we have differential equations of two variables if c is equal to a function f depending on x and y variables. Right, is a function of two variables with continuous partial derivatives in the region R on the xy plane, then it differential its differential is dc equal df over dx. Okay, let me just do this again, read this again. dc is equal to partial x dx plus partial f partial y dy, right? So in other words, if this is continuous, okay, on the region R, okay, then the differential is going to be in this form, okay? Now, think about in calculus 3 when we study. I'm not going to go through a lot of this stuff because again, it's going to be way too long explanations. Okay, let's say that this book right here. Let's say that this book right here was this book right here is an xy plane, right? So if I have an arrow shooting out of this book, this is going to be another function, right? And that function is called, if this is x and y, then the function coming out of the book is going to be c, right? So c. So that means the c is a function that depends on x and y, okay? So now, that will be considered what is called in calculus 3, it's called three-dimensional, okay? Three-dimensional. Now, in the special case, when function f dependent on x and y equals z, where z is a constant, then equation 1, which is this one right here, implies that partial f over partial x dx plus partial f partial y dy equals 0, okay? Now, that is the convention that we use, that if in a special case this function, okay, equal to certain constant, okay, then this is going to be 0 in this side, okay. Now if you think about it, you take the partial derivative of a certain function on the left side, okay, on the left side, and you have a constant on the right side, what are you going to get on the right side? Okay, so if you take a derivative of a constant, it's going to be 0. Okay, so that's why they're trying to say in this one. Now, the formula that we're going to use, okay, is going to be this one. This one is very important. It's very important. M of x comma y dx plus n of x comma y dy equals 0, okay? Now, this right here is another important piece that tool that we're going to use, okay? Partial m over partial y equal partial n over partial x, okay? Now, in this case right here, okay, I have m. Now we do the steps, okay? This one only was a short introduction to this topic, okay? Now, at step 1, see if the given differential equation is in the form, is in the form m of x comma y dx plus n of x comma y dy equal 0, okay? And checked for exactness, okay, by verifying that the partial m over partial y is equal to the partial n over partial x, okay? Now, this is step 1. And step 2, we integrate m dx with respect to x to find f, okay? Such that the function f is going to be f of x comma y equal the integral of m of x comma y dx plus g of y. Now, this is another important, okay? And I say it again, this is important. This piece right here, okay? The g of y is acting like a constant, but it's not a constant like a regular integral, okay? It's not a regular integral, it's a constant function, okay? Now, that constant function is going to be very important, right, for us, because we are going, at the end, we are going to integrate to find that g of y, and then we are going to substitute back into this integral, okay? So that is going to be our final answer, okay? Now, of course, the final answer is going to be equal to a certain constant c, okay? But again, this is very important because we are going to find g of y to substitute it back into this integral, and it's going to be part of our answer, okay? And then after we find the integral, we set it equals to, sorry about that, equal to n, okay, n x comma y, okay? Now, and step 3, we take the partial derivative respect to y and see if anything cancel out on both sides of the equation, okay? The book doesn't say that, but my goal right here is to help students who are taking differential equation, okay? Because again, like I said before, sometimes you go to the class and some of the teachers, they start explaining a bunch of theory in mathematics that really don't help you too much on solve a differential equation, okay? Now, this is not in the book. Again, it's not in the book, but I put it right here because that is the way that I learned, and I learned stuff by doing the simplest way, okay? Because that, that's it. I mean, why should I go and find a complicated way to solve a problem when the explanation can be easily understood in a simple language, okay? Okay, now, so to see that we take the derivative with respect to y and see if anything cancel out on both sides of the equation, okay? In step 4, integrate with respect to y, okay, to find g of y. Again, we'll integrate with respect to y again, and substitute in the integral found in step 2, okay? Let me go back to this explanation real quick, okay? What I mean that we integrate on both. We integrate with respect to x first, and at the end we integrate with respect to y, okay? So I don't want anybody misinterpret me and say that we integrate with respect to y twice. No, just with respect to y at the end to find g of y, okay? Because we start integrating with respect to x. Okay, so we integrate with respect to x first, we get this form, and then at the end we integrate with respect to y to find g of y. Okay? Let me just do one problem, and hopefully I have enough time to do one problem. Okay. Let me just erase this. Okay, we will be doing number 19 in this book, okay? Number 19. Okay, number 19. Number 19, we get 4t cubed 4t cubed y minus 15t cubed. I'm sorry, it's t squared. Minus y, okay, minus y, dx, I'm sorry, this is dt, 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 okay, plus, open parenthesis, t to the 4th power plus 3y squared minus t dy equals 0, okay? Okay, so That is our differential equation, okay? Now, if we look at this differential equation, we see that it is on the standard form. Why? Why is it the standard form? Because we have this piece belong to this derivative plus this piece belong to this derivative is equal to 0, okay? The only difference that we have right now in this case that we have t instead of x. But that is not a problem because we still can, t is representing x in this case, okay? What I'm going to do right now, I am going to call it this one right here because it has a dt. I'm going to call it m, and this one because it has a dy, I'm going to call it n, okay? Now, I am going to take the partial derivative of this and see if I, of both of this, and see if I can actually make that satisfy this equation, okay? Partial m over partial y equal partial n over partial x, okay? Now, let's take the partial derivative of this, okay, of m, partial m over partial y, okay? Remember, this is very important. If I take a derivative, partial derivative of m with respect to y, I'm going to do the opposite, okay? The opposite. Over here I have a dt, so I have to take the derivative with respect to y. Over here I have a dy, I have to take the derivative with respect to t, okay? So if I take the derivative with respect to y, I get 4t cubed partial derivative, right? I am treating this as a constant. 4t cubed is acting like a constant in front of the y, right? I'm taking the derivative, partial derivative with respect to y. So the derivative of y is 1, okay? 1 times t cubed, 4t cubed is just 4t cubed, right? Now, the partial derivative of negative 15t squared is 0. I am treating that 15t squared as a constant, so that is 0, okay? The derivative of negative y is negative 1, okay? So that is the partial derivative of m with respect to y. Let's do n with respect to t. N with respect to t, okay? So what is the partial derivative of this, of t to the 4th power is going to be 4t to the 3rd power, right? What is the partial derivative of 3y squared? Well, doesn't have any t in front of it, so that is a constant, so therefore is 0, okay? What is the partial derivative of negative t? The partial derivative of negative t is just negative 1, okay? Now you can see that both partial derivatives are the same. So that means that this is true, okay? Now I'm going to integrate m, okay? If I integrate m, I'm going to find f, right? So I'm going to integrate m, okay? Which is equal to the integral of 4t the 4th y minus 15t, sorry, this is supposed to be t, okay? Okay, 15t squared minus y, right? Okay, dt, okay? Now I am integrating I am integrating with respect to t, okay? what do I get? If I integrate this, this is going to be 4t. If I integrate this, I'm sorry, this is, okay, that's supposed to be t to the third power, okay? I am just integrating the original m, okay? So if I integrate this, okay, it's going to be t to the fourth over 4, right? Of course, I gotta have the y in there, okay? If I integrate negative 15t squared, it's going to be t to the third divided by 3, okay? If I integrate this one right here, the coefficient of negative y is negative 1, so it's going to be negative ty plus, okay, plus g of y, okay? Now, let me simplify that. This cancels with that one on the top. This goes over here 5 times with the 15 on the top, okay? Of course, carry the negative, okay? So this is equal to t to the fourth. Sorry, my marker is not working so good now. So t to the fourth minus t to the fourth y minus 15t cubed, I'm sorry, minus 5t cubed minus ty plus g of y, right? Now this is the integral, okay? This is the integral, which is, this is f of t comma y, okay? Now my next step is to take the partial derivative of this, okay? I need to take the partial, okay? When I take the partial, let me just do it on blue. If I take the partial derivative of that, that is going to be, if I take the partial derivative with respect to y, okay, what do I get? Remember that I'm taking the partial with respect to y, okay? If I take the partial with respect to y, this becomes t to the fourth. Why? Because I am taking the partial with respect to y. This right here go to 0. This 5t cubed go to 0, okay? So now I take the derivative of negative ty. Well, I'm taking the partial derivative with respect to y. So that is going to be negative t, okay? If I take the partial with respect to y of g of y, that is going to be plus g of y prime, okay? And I'm going to make it equal to n, okay? I'm going to make it equal to n. Well, what is n? N is t to the fourth plus 3y squared minus t, okay? Notice that I have dy, but I don't worry on writing that stuff anymore, right here in this case, okay? Now, if I subtract 4t over here, let me just do it in red, on black real quick, okay? If I subtract t to the fourth, if I subtract t to the fourth, okay? If I add t, on both sides, what is going to happen? See, this cancel, that cancel, okay? This cancel, and this cancel, okay? And I am left with g prime of y equaled 3y squared, okay? It's very important that you pay very good attention to this one. If nothing is canceling out, you might have a problem. You might done something wrong, okay? So it's a very good thing to check, okay? Now, I am going to integrate on both sides, okay? So when I do the integral on both sides, I get what? I get g of y, sorry about that, g of y equal, if I integrate this, it's going to be equal 3y cubed over 3, okay, which is equal to y cubed, okay? So the final answer is going to be this plus this, okay? This plus this. This is g right here. This is g of y. So I am going to substitute that g of y right there, okay? So it's going to be equal to, the final answer is going to be equal to t to the fourth y minus 5t cubed minus ty plus y to the third power equals z, okay? That is the answer, okay? I hope this helped. Anybody who's taking differential equations, thank you for watching.